So this is probably the kind of most important slide you'll have for the whole class, or at least the overwhelming majority of the class, because this tells you everything you need to know, pretty much everything you need to know about all of the classes of nutrients that we're going to be covering. So we got 6 classes of nutrients. Our macronutrients, and if we break this down from a fundamental standpoint, macro means big, micro means small. So our macronutrients are the nutrients we need in big quantities. These are the ones that contain our calories. So carbs, fats, and proteins. Carbs, abbreviated CHO, is because the chemical component of all carbs is only carbon, hydrogen, oxygen. So like a glucose molecule is C6H12O6. So that's why you get the CHO for carbs, because that's the skeleton for all of them. So macronutrients contain energy. They're the ones that are going to contain calories. Nothing else contains calories. Nothing else. So unless it is a fat, a carb, or a protein, it does not have calories. I can't tell you how many times students will say that vitamins and minerals have calories. They do not. The only thing that has calories are carbs, fats, and proteins. That's it. Now, yes, you can get me on the technicality that alcohol is a separate category, and alcohol has calories. But we're going to touch on alcohol in its own kind of section there. Your body doesn't or isn't able to use alcohol for energy. So that's why you don't classify it as a type of nutrient, because it doesn't give you any benefit. If you ever heard the term empty calories, that's what alcohol is, because we'll find out that when you consume alcohol, your body has to metabolize it in your liver before it can use it. So you can't just say drink down, a bottle of whiskey and use all those calories. They have to be turned into fats first before you can actually use them. So every calorie you get from alcohol turns into fat, which is kind of a not so great thing if you think about it. But anyways, getting back here, macronutrients, carbs, fats, proteins contain calories. You'll see calories abbreviated kcal, which means kilocalorie, or calorie with a big C. But these are the calories you see on a food label, is a kilocalorie. Does anybody know what a calorie actually is?
Is it the amount of energy to turn 1 gram of, or like to raise 1 gram of water by 1 degree Celsius or something like that?
You're close. So calories are not something that has energy. Calories are a unit of heat. And 1 calorie with a small c, which is 1/1000th of a kcal, represents how much heat is needed to raise 1 milliliter of water by 1 degree Celsius. So calories, by definition, are a unit of heat. But calories represent potential energy. Potential energy, for all of you kinesiology students out there, means that you don't yet have energy, but you have something stored up to kind of use for later. It's kind of like if you are standing at the top of a hill and you start rolling down it, the higher up you start, the more potential energy you have. And then as you start rolling, you'll roll faster and faster down the hill, turning into kinetic energy, your actual energy of motion. So calories are essentially your potential energy. The only usable form of energy we have is ATP. ATP is adenosine triphosphate, and that is your body's energy currency. One of the easiest analogies to think of is with oil and gas. So you go and you have your oil derrick. It's a terrible drawing there, but it shoots oil out, right? Can this oil in this barrel now do anything for me?
Not yet, not until it's processed.
Exactly. So you take that to your refinery, you get car food, right? So this is bioenergetics in a 3-step process right there. You dig calories out of the ground in the form of fats, proteins, and carbs. You then send those calories off to your refinery, where it is then turned into gas, which we use as energy, or ATP. So that's about the simplest way I could break that down for you. The calories you have are not energy. They represent potential energy. The ATP they turn into, or they break down and convert into, is your energy. So how much energy do you get directly from these? 0. But the potential energy you have is pretty huge. The only energy that our body uses, again, is ATP. Our body does not use calories for energy. We can't. You know, that'd be like going up into your grocery store here. If I go down to Fry's and I try to pay them with, I don't know, let's say Canadian dollars. How likely is it that they're going to accept that? So when you're thinking energy, remember only ATP. Now, a couple other things to note here. Organic and inorganic. This has nothing to do with, like, say, buying organic foods at the grocery store, or this is an organic product. No, these are chemistry terms. Organic means that it is carbon-based. Inorganic is non-carbon-based. So every one of your macronutrients plus your vitamins all are going to have carbon in them. Minerals and water do not have carbon in them. Therefore, they are inorganic. So for any of you that have taken Chem 1 or Gen Chem 1, that is also known as inorganic chemistry. Organic chemistry has its own thing, its own complete study, because you are studying everything carbon-based. Also why, again, carbs abbreviated CHO, that C is your carbon. Now, with carbs and proteins, these are both going to give us 4 calories per gram. Fats are going to give us 9 calories per gram. Micronutrients and water give us no calories. We cannot turn micronutrients or water into energy. We can only turn macronutrients into energy. So anytime someone says that, you know, they're taking that B12 drink is going to give them a bunch of energy, no, it's not. Vitamins, minerals, water give you no energy. There's nothing in them that gives you energy. The whole purpose of having micronutrients is to support the processes of macronutrients. There was an old commercial chemical company called BASF, and their slogan is, "We don't make the products you buy, we make the products you buy better." And that's what vitamins and minerals do. They don't give you any energy, but they make the process of turning carbs, fats, and proteins into energy better. They help with efficiency in a number of things, not just energy production, but they are the ones that are going to make sure all of our body processes work better.